forearm section, and those wires come through, one on the top, that's for servo set, and one on the bottom, that's for power set, and then they get attached through a central hole. This is the torque bar, and these are the power cables, and there's a round. Okay, so getting pretty near now to having final positions, maximum packing density in the hand. That's 9 SCS double or 0009 servos. 4 fingers, 1 thumb, now with direct rotation at the base, which is an engineering simplification to a problem that biology, evolution, whatever, has solved in, I guess, what you'd have to consider a slightly suboptimal way. The basal joint of the thumb, this thumb joint here, the base joint, is the most operated joint in the human body. Last time I checked. I'm no doctor, but that's what I have read, or what I remember reading. And it's yeah, it's a complicated one. In the human body, this is a saddle joint. It's got a lot of extra muscles to stabilize. Now that contributes to a big part of our general strength and dexterity. But the joint itself is different from the fingers, primarily because you can drive rotation directly. The base joint, at least. The thumb does other stuff and is stronger and is very useful. But at the base joint, it's about adding in that extra rotation. And the thumb, the human thumb, does it with ligaments and lots of muscles. And as an experiment in this one, I'm going to do it by driving the rotation directly. So the 9th servo is tucked in here. I'm going to try and add a bearing, the same as with the wrist, to reinforce that joint, because otherwise I think it's going to break the servo pretty quickly. And I've spent a lot of time going back and forth on the finger positions. I want to get that shape in, and yet not have it end up too large. Everything has to clear. The fingers are going to go in cartridge style, so they're going to plug in from the front. These ones I think are just going to be fixed, and I am toying with the idea of actually holding it on by bearings at the back, so that the whole front structure is slightly flexible, and that could even be enhanced. You can actually add axes of rotation to really give a lot of movement to the palm. What I should probably do is the simplest solution at this point and just print it, but it could clearly be done, and it would add a nice extra dimension, visually and functionally. Practically for now, you've got to think you don't need it, so I will I will just go for completion at this point. So this part needs to be printable. If this part is printable, which holds together the palm section, rather the wrist pitch servo and all of the 9 servos in the palm, and then the cartridges give rise to the knuckle joints, and the thumb is reinforced, then that means it can be physically made. So the criteria, as obvious as it sounds, is that the design is defined to be done in stages when it can be physically made. One can be assembled, and then the wiggle room that comes is the amount of fettling that is required. So the first draft of the prints are normally going to have a fair amount of errors, but it should be possible by trimming and struggling to assemble it. By the time it's fully published, it wants to be very, if not simple, and certainly straightforward. It's the little catches which are the problem, and the big problem to avoid in the hand in that regard is when all the tendons go in. So there's another, what, 17? Yeah, 9 and 8. Another 17 tendons to be routed, plus the springs. That can be either relatively fast or very, very time consuming. So I'm really working on the processes and the techniques now to add tendons rapidly. I mean, mechanically, physically, they've still got to be built. So every minute you can shave off the assembly time for a tendon setup when there's 17 of them to do is valuable. So the aim really now is to get that process, to get that automatic as much as possible. Anything where you've got to think about it as you're assembling, it's just so much slower. And obviously I want to make this a lot prettier. This is just the first block to check all my volumes and clearances. And when that's finished, that wants to be nicely curved. That's not too bad. It's got a start to that shape up here. It's a bit square, it's a bit block. I'll try and break that up. But that is the progress on the arm and the hand. The arm has a reasonable set, which I will release this end of this week, hopefully. I can release the STLs I've printed, certainly. There'll be trays and separate parts. No instructions yet, of course, but you can see how it goes together. Fans go behind here. These are protections for the fans. They're what, 25-inch, 1-inch fans. I'm going to need to block that off at some point to force air forwards. The wiring does go. I will, I guess, film a quick video showing that and stick it on the end. They pass through here, they go around here, they come out there, they go through here, they go on top, and they come around the top of this the same as on the SO arm and then down that hole. And you have to start building it as a result here. This part actually slides in afterwards, but this servo 4, and then you go backwards assembling that on top of that, this around that, that slides into this, and then this is exactly the same as it was on the SO. And that will take you down to the wrist, in fact. Quite pleased with this part. I think that looks quite nice. Prints okay this way up. Obviously a lot of supports to remove, but it's strong. Stronger than I expected. The middle, of course, is held together by the servo screws there. And that translates wrist and pitch. It might have to get a little bigger to put in some of the tendon bodens. I'm not sure yet. We shall see in the wash, and that'll be the next draft. But second draft out for the arm.
Okay, let's just have a very quick look at the wiring. This is exactly the same as the SO arm. The only extra is a decent, this is 18 DW AWG, American wire gauge. Just power and ground, red and black. Signal will come off the same servo wire as the main arm servos. Just voltage in the hand will be less, 5 volts. You can also use it to drive the fans. So that comes off for under the armpit. That's not brilliant. I think they shouldn't be twisted like that. Okay, that's better. Right, so the arm in the normal position is going to be like that. That's the armpit looking in there. One set of wires on the outside. These are the 12-volt lines and just a standard daisy chain connection for the STS3215s. This is the power going down to the hand and the forearm. Comes out of a channel up in there, comes out there, comes through there. Now, when you assemble this cable wants to pass from the elbow to the other side, and then that one's going to then connect up to the yaw in the wrist. And the power is going to come round through there. This part is detachable, it slides in, and it comes round from there, down there. And there's a gap, bigger than this in fact now, there's a gap on the bottom. So that's fairly straightforward to do now. And again, a little bit sticking out, and that's just the way it is, like the funny bone really. and then down into the forearm section, and those wires come through, one on the top, that's for servo set, and one on the bottom, that's for power set, and then they get attached through a central hole. This is the torque bar, and these are the power cables, and there's a round quarter round there, and there's a half round up the top. So that all clips together like that. All of these cables have to be fed in that little gap there, and there's a clearance on the front of that. So you can assemble everything into that gap and pull these wires tight as the top goes on. Pull that one to the side, pull that one tight, and then this engages underneath the torque bar on that side and clips down into that. It should be a snug fit on the bearing. Make sure none of the cables are trapped underneath, and then there are 3 screws to hold it, which will need inserts. One there, one there, one there. So that all screws together. You can see that where the rest of the inserts are. Up here there's 4 of them, made a bit of a mess of that one, doesn't matter. There's a spacer in the middle there, which in fact looks slightly out of position, so that will need cranking up. There's a screw now on this which will hold it together, so there's an extra spacer, an extra insert there. Okay, so that is how that all goes together. Bearings in here, 4-piece split there, screwed through there. Yes, so the order is important. Because of the wires, you have to start at the elbow. So the elbow one goes in first, all of these wires are connected, all of these servos are programmed, the IDs and just the IDs for now in fact. So these wires go back as you assemble. This joint assembles first, so upper elbow assembles first. Then over the top of that, humeral, and that clamps together. And there's a bearing in there, and there's an extra bearing in here. This piece then slides in, so then this is all assembled. Then these 4 parts assemble bearings pressed on, this bearing pressed on, these pieces pressed in, and then those screws go in, and that will hold all that together. This servo can then be fed in, all the wires connected up, everything threaded through, and then this base will slide in. And then when you screw those down, that will hold the servo in position. So the servos are not always retained. In fact, they're all retained apart from that one, but it doesn't need to be, because there's no forces on it apart from torsion. So that is the order. Upper elbow, humeral, shoulder pitch roller, shoulder pitch, base, and then you can come back down, do the elbow and then the forearm.
को जिंदा रखते हैं।